Hi there. This is a very basic introduction to understanding statistical models. I need to warn you in advance, this is a very basic introduction, basically just a way of thinking about modeling problems. And just for the sake of example, I'm going to use a simple or sample mean and basic linear regression between two variables. Also a great chance for me to experiment with a new graphical pen. So I'm gonna try also drawing stuff on the screen, and hopefully that's gonna make more sense and be more instructional. So what are models? Models are basically representations of reality, and because reality is sometimes complex, we want to make sure to create simpler models so they can probably explain certain phenomena. And as we all know, and as the saying goes, all models are wrong and some are useful, and we need to keep remembering that one. One of the basic example I'm going to use to show you how to create a model is sample mean. Here we have 20 players and their body weight, and as you can see, these are the body weights in kilograms, and here we have a graph. What we want to do is to create a model to represent this group of the players or athletes, and basically aggregate all these points into one point, which is our model. And as we all know, that's usually a mean or average. So here is I created two models, model 1 and model 2. I'm gonna play a little bit with the model 1. What we want to do is to find a spot, for example here, and then find the errors. What we want to do is to minimize the errors. So if this is our model, in this case mean, we want to minimize the differences between points and this. So this point here, these are the error terms, the error. As you can see in model 1, we can choose, let's say, 71, and we can see on the screen a thick line representing a model 1 or the mean. Here we have the error term, as we said, so it's a difference between the dot, in this case body weight, and our model. So this minus this, that's the difference, error. And since we want to avoid or remove the negative term, we can do two options. In this model we're gonna square the error, and in this model number 2 we're gonna take the absolute of the error term. As you can see here, it's the same number, just without the minus in certain cases. Squared, that's a usual procedure in statistics, squaring the error. In this case we remove the minus sign, we make everything positive, and that's important when we sum up the error. This is a total error. And also we penalize the dots or outliers that are far away from the model, because this distance d is squared. Hopefully that's understandable. So we have a model that's a line dot, and we have a total error, so it's the difference between the line and each point squared and summed up. So what we are trying to do is to minimize the total error. So we want to find a model that suits our data so that the error term is minimal. Let's say we we pick up 68. That's pretty up. At the bottom we have 5,275. We try to increase, let's say 75. Okay, it's smaller. Let's try 80. Okay, even smaller. 85. Okay, it's climbing up, so somewhere between I don't know, 75 and 85. Let's say 78, 77. I mean, and then you can go all day long about it, and this is a problem of optimization. So we want to find a number, the model, in this case the mean, that minimize the error term. And as we all know, that's a mean, and this is basically a variance. Or if you divide this by a number of subjects and square it, we're gonna get a standard deviation. So anyway, we can use a Excel solver. We go to the data. This is usually add-on. So go to our solver. So the objective function is the error. We want to minimize this number by changing the model or the mean. And we're going to go solve. And we found the number, that's 79. If you do the mean, oh sorry, there's no mean function, average in Excel of these numbers, we're probably going to get same number, 79. Let's see if the rounding maybe hides some details. Trying to, okay, that's it. So basically we can look at the mean of the sample as a statistical model that explains that certain data set while minimizing the error. Another way to look at this, or another way to deal with the error, is to use absolutes. So in this case, model 2, same procedure. We define a dot, let's say 85. You can see the orange dot. In this case, we used the absolute term. In certain situations, it's better to use this one. In most of the statistic tests, inferential statistics, we are using a error squared. Sometimes it's better to use absolute because it's not so sensitive to the outliers. So you might say it's more robust. This one is very sensitive to the outlier. Let's say, yeah, same thing with this model. We want to find a number that minimizes this error. Again, we can use the solver. So we want to objective function. So the objective is to minimize the error and trying to find the mean. So as you can see, it's slightly lower. Okay, using these two procedures, you can play with how these two functions deal with the outlier. So let's say I'm going to plug in one outlier, that's 120. It's outside of the axis. So that's our outlier over here. And we're going to repeat the procedure. Just going to try to find a model that minimizes the error. That's 81. And same thing for this one. So I want to minimize this number by changing the model. 78. As you can see, this one jumped pretty higher than this one compared to the previous scores. Similar thing with regression. We have two variables, body weight and height, and we want to try to find a correlation between them, or basically a linear function. So what we're trying to do is to try to find a line, these points, and also minimize the errors. So we want to minimize these guys. These are called the residuals. So one way to think about it is, you know, mathematically, you're trying to find the best line using is it a matrix algebra and that stuff, and you end up with the slope of the line and intercept term. But thinking more about the model, what we're trying to do, you want to fit a line, any given line. So it could be this. We are trying to find a line that minimizes the errors. So same thing as with the simple mean. We use two models. In this case, we have two parameters. So we have a slope and intercept. So it's a basic linear formula. That's why it's called a linear regression. So basic linear formula is y equals b0, that's intercept, plus b1 and x1. So in this case, this is an intercept term, and this is a first coefficient, or the slope of the line, because it's only a single one variable. We can also have multiple guys over here, so b2, x2, so this could be age or whatever. And so with the linear regression, we are trying to find and this coefficient of or the slope, so slope and intercept. So same thing with the previous model, but this time we need to play with the two variables. So let's say I'm going to use a slope of 2 or 3, see if it is going to pop out, or 0.3. Okay, so now we see the line, and same thing, we have predicted value, so that's basically points on the line. So predicted is, we predict the body weight using a height, so this is a predicted body weight, and we calculate the error between the predicted and real. So basically predict the distance between any given athlete, or in this point, or in this example, a point, and our linear model. So basically, a linear model is just a formula for a line. And as in the previous example, we want to sum up all these errors. So all errors over here, we want to sum them up. But first, we need to get rid of the minus sign. So in the first example, we're going to use square. So you need to square the error. In the model number 2, we're going to use the absolute of the error. You can manually play, so 0.35, and try to find the best fit by minimizing total error, or you can use a solver in Excel. In this case, the objective function. That's a term also from machine learning. So you want to minimize the objective function of the model is to minimize a certain number. So we want to minimize the error by changing these guys over here. So Excel is gonna, go through a certain iterative process and try to find the best solution. So you're gonna solve, and you get 0.36, and intercept is 22. So this linear model gives us the minimal error. We're gonna do the same thing, but in this time we're gonna use absolute as a way to get rid of the minus in the error. Same thing, we're going to use solver. We want to minimize this one by changing these two and solve. It's pretty similar. Again, this one is less sensitive to the outliers, but this is the one we use in statistics all the time, the square one. Some machine learnings techniques use the absolute one because it's more robust and maybe it's less sensitive to outliers. If you create a linear, let's say like this, intercept and slope. So we're going to use a formula in Excel. Intercept, y is our body weight, and x is our height. And we want to find a slope. And as you can see, the numbers of the intercept and the slope are the same as we got from trying to fit the model into a data set instead of trying to find just a different way of thinking. That's why it's so interesting. So we get the same numbers by using optimization way of thinking, just trying to fit certain mold or model into our data set and trying to minimize the error. As you can see, 0.36, 0.36, and 22 for the intercept. Okay, I urge you to take this workbook and try experiment, maybe change some numbers and see how it is affected by the outliers. That's it all, folks. Till next time, enjoy the statistics.